In this video, I briefly want to go through the process of analyzing some project risk. This is the same kind of an analysis we do with standalone risk for a single individual asset. And we need some basic data. The data that we need is we need to have some probabilities of economic conditions. Given these economic conditions, I'm sure you realize that in an optimistic, growing, booming economy, companies sell more, they have greater cash flows than they do in pessimistic or recessionary times. So we want to predict the net present values that will occur or that we expect to occur under different economic conditions. We need to have an understanding of probabilities. What's the chance that these conditions will happen? Those are entered here under probability. And by the way, you enter these as the decimal form, not the percentage form. And then you enter the net present values. And here we have a series of projects with their predicted net present values given an optimistic economy, an average, and a pessimistic economy. You can also use this for almost any variable you can think of. What do you think the average sales will be? Enter the sales expected under here. The statistics will play out for the average and the risk of that prediction. Likewise with cost of goods sold or any variable that you can think of. How about units that are sold? We could do it that way as well. So eventually, once you enter the data, we have to look at the statistics. And we have basically 5 statistical measures here. The expected return is the average. That's the mean. And as you see, as we look across here, the highest average is asset B. And the lowest average, if we look across here, is asset C. The standard deviation is the measure we typically talk about with respect to risk. And as you look across the board, you can see that asset A far and away has the, oops, I'm sorry, that's not right. B far and away has the highest standard deviation. It should be the riskiest of the projects. Asset C has the lowest risk, $8,000 versus, again, asset B that's at $94,000. The coefficient of variation is the best measure, if you will, of making comparisons, better than standard deviation. But as you look across this lit line, you can find that asset C far and away has the lowest coefficient of variation at 0.064. The range is just simply the highest score minus the lowest score. It's a measure of risk, and again, asset B has the greatest range, but it doesn't take into account probabilities. So again, if you want to measure the risk of net present value, find the average and then understand something about the underlying statistics. This is the worksheet that will help you do that.